Moving on to the next factoring examples, we have to factor this polynomial here. Now, when doing this example, we're going to follow the same steps that we followed in the previous video in the first factoring example, and I wrote out the steps here. However, in this video, we'll be moving at a bit of a faster pace. I won't be doing as much explaining. So if you're not comfortable with these steps, make sure you go and watch the previous video where I go over these steps in a lot more detail and a lot more explanation. So the very first thing that I did with this polynomial was I took it and I rearranged it from highest degree to lowest degree. And I actually didn't write that step out in the factoring steps, so you may want to add it in. Before doing all these steps, you want to always make sure that the polynomials from highest degree to lowest degree. So the first step that we take is that we have to factor out any common factors. And a common factor in this polynomial that we could take out initially is this negative 2x. You always want to take out a negative if the leading coefficient is negative, just because working with a positive leading coefficient when factoring is a lot more easier. And notice how we can also take out a 2 from all of these terms and an x variable. So then taking all these terms and dividing them by negative 2x, we end up getting this polynomial in the brackets. So now we can move on to step 2, and I labeled this polynomial here as f of x just so we can refer to it easier. And step 2 says that we have to find factors using the factor theorem. So what we would do is we would take this polynomial and we would plug in a bunch of x values, plus 1, minus 1, plus 2, minus 2, etc., etc. And we would keep plugging in values until we get a value of 0. And then we know that x minus that k value would be a factor. So plugging in 1 into this polynomial, we get a value of 0. So we know that x minus 1 or x minus that k value is a factor of this polynomial here. Now we can move on to step 3. So we have to find the quotient by dividing the polynomial by the factor that we found in step 2. So the factor that we found in step 2 was x minus 1, and that's a factor of this polynomial. So we take this polynomial here and divide it by that factor. Now, I didn't write out the details of the division. However, as usual with step 3, as we mentioned in the previous video, you should always get a remainder of 0. And the quotient that we end up getting is x cubed minus 4x squared minus 1x plus 4. Now, I would highly suggest that you pause the video right now and try to do this long division yourself. Actually, you should try long division and synthetic division to make sure that you're getting this result, just so you can get some extra practice with dividing polynomials. So moving on with the factoring process, so far what we got is the negative 2x that we factored out in step 1. Actually, I'll write step 1 here. Then we had this polynomial to work with, and we found out that x minus 1 was a factor of it. And then we divided that polynomial by x minus 1 and ended up getting this quotient in step 3. So now we can move on to step 4. Now step 4 says if the quotient that we got in step 3 is a quadratic, then we can just factor it using techniques that we already know of, so quadratic formula, or we can use decomposition. However, if the quotient has a degree that's greater than 2, then we have to go back and repeat step 2. And notice how the quotient that we have remaining has a degree of 3. So we're not just going to be able to factor it smoothly because it's not a quadratic. So we're going to have to go back to step 2 and now factor this polynomial using the factor theorem. So going back to step 2, for this polynomial, I labeled it as g of x, so we just avoid confusion with this polynomial here that I labeled as f of x. And we have to use the factor theorem to find factors for it. So again, we would just plug in a bunch of values for x until we get a value of 0. So trying plus 1, minus 1, plus 2, minus 2, etc., etc. And then if we plug in 1 for the x values of g of x, we get a value of 0. So we know that x minus that k value of 1, or x minus 1, is a factor of g of x, and we can move on to step 3. So after finding the factor of x minus 1 in step 2, in step 3 we take this polynomial and divide it by that factor x minus 1, and we end up getting a result of x squared minus 3x minus 4. And as usual, you should get a remainder of 0 at step 3. You should pause the video and try to do this yourself and make sure that you are getting the same result. So continuing our factoring process, we had the negative 2x initially, then we factored out an x minus 1, and then we took this polynomial g of x and factored it into x minus 1 again, and our remaining quotient of x squared minus 3x minus 4. So now we move on to step 4 with this remaining quotient here, and because it's a quadratic, we can just use the quadratic formula or decomposition if it factors smoothly. And in fact, it does factor smoothly. So we would write out all of these factors again, and this factors into x minus 4 and x plus 1. Make sure that you're able to get this using decomposition factoring. Now, one thing I want you to notice about this question that's unique is that this x minus 1 is a factor that appears multiple times. It appears twice. And that's a point that I want to make with this specific example, is that you can have factors that appear multiple times. And if they appear multiple times, you can rewrite them in a much nicer way. So since this x minus 1 appeared twice, we would put a squared here. And then we'd have x minus 4 and x plus 1. And this ends up being our final answer. That's the factor form of this polynomial. So as I mentioned, we followed the exact same steps that we used in the previous video. And in this particular example, we went at a bit of a faster pace. So if you're still not fully comfortable with these steps, as I mentioned before, go and watch the previous video because I go a lot more into detail with each of these steps, and you can see a lot more clearly how the factoring process works.